All right, this one is a little bit more complicated, so I want to kind of go back to what we did earlier. Actually, in a previous problem, we had something, and it had variables in it, so I'm going to kind of modify it. But what if we had like 1/4 and 1/8, and we wanted to know what would be the common denominator? Well, we could look at these numbers and just say, well, the common denominator would be an 8, because we know enough about numbers that we know that 8 is a multiple of 4, and it's a multiple of itself. But let's see what's really going on here. If we were to break down this 4 into its prime factors, that would be 2 times 2. And if we were to break down the 8 into its prime factors, that would be 2 times 2 times 2 is 8. Okay, I want you to look and see what's going on here. We have a set of 2's that they have in common. So I'm going to write that down. Then they also have another set of 2's that they have in common. So I'm going to write that set down. I'll put arrows and lines here so you can see which ones are which. Now, they don't have any other 2's in common, but we have an extra 2 here that we have to account for also. So 2 times 2 times 2 is actually 8. This is really how we're finding our common denominator. We take what they have in common, and then we have to account for everything else. Now this is going to come into play when we start working with larger and larger rational expressions. Before we can see what they have in common, we have to factor down each one of these. So let's see, that's going to factor into x and x, and our factors of 12 that will somehow give us a 1 is probably going to be 4 and 3, and negative 4 and positive 3 would give us a negative 1. Now for our second denominator there, let's go ahead and factor it down also. So here we would have, let's see, factors of 20, probably 4 and 5. If we did a negative 4 and a negative 5, that would be a negative 9. Multiply them, we get a positive 20. Okay, so now let's try to figure out the least common denominator. Just like we did up here, we have to look to see what they have in common first. We have a common x minus 4. So I'm going to write that down as part of the LCD. Now we only do it once because they have, both of them have an x minus 4. It accounts for 1 in each set. Now we have to also take everything else. So we have to account for the x plus 3. And we also have to account for the x minus 5. So our LCD is actually 3 different binomials in this problem.